lesson is 31, adding integers and collecting like terms. What's our objective, class? Get ready?
Adding integers and collecting like terms.
Good. We're going to do two parts today. The first part is really a predecessor for the second part. If we can add negative and positive integers, then you will be a lot better off on the second part. So negative and positive integers, if you had negative 4 degrees and it got 10 degrees hotter, so you would go up 10 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 degrees. Where are we at on the scale? If 0 is here, that's 1 degree, 2, 3, 4, 5, 6. That's at 6 degrees. So basically I said negative 4 degrees, then I added 10 degrees, and I ended up at 6 degrees. So we're going to talk about how do we calculate easy negatives and positives. So one way is to use a counting method. I'm going to show you another way to use absolute value. One more example. If you're in debt $5, you're behind $5, so we call it negative $5. So debt is negative, but then if someone gives you 15, it's positive. So really, you're going to end up with $10. So again, you can count it on a number line. I'm going to show you a way to do it with absolute value today. All right, so let's review number line. Negative 3, I would go over 1, 2, 3 units. Here's negative 3. And then I'm going to add on a positive 5. So I'm going to go right 5 units. So I'm going to go up 1, 2, 3, 4, 5 units. Where am I? There's positive 1, there's positive 2. My answer is positive 2. Here's the way to do it with absolute value. If the signs are different, take the absolute value, so just look at the positives, and subtract the two numbers. If the signs are different, subtract. What do we do when the signs are different? Get ready?
Subtract.
Subtract. 5 minus 3 is 2. And the answer takes on the sign of the greater absolute value. This number is more powerful. It's the greater absolute value. It's farther from 0. So it has more power. The sign will take on the sign of that number. So let's try another one. Positive 3. So I started here. 1, 2, 3. I'm here. Now I'm going to subtract 5. Now I know it says add, but I'm going to add a negative 5. Well, negatives goes this way. So I'm going to go back 1, 2, 3, 4, 5 units. Where am I? That's negative 1, that's negative 2. So the answer is negative 2. Using this absolute value method, take the absolute value. The signs are different, so I subtract. What do I do when the signs are different? Get ready?
Subtract.
Subtract. So I'm going to take 5 minus 3, which is 2. But the answer takes on the sign of the greater absolute value. That absolute value is farther from 0. It's a negative, it has more power, so my answer has to be the same sign. Kaylee. Oh, these are absolute value. So if you remember, the absolute value of negative 2 is 2. Okay? All right, how about this one? This time the signs are the same. The rule is for this, take the absolute value. That would give me 3 and 5, and the rule is add. When the signs are the same, add. What do we do when the signs are the same? Get ready?
Add.
Add. So 3 plus 5 is 8. Then what about my sign? Well, the answer will take on the sign of each number. They're both negative. The answer has to be negative. Does it make sense on the number line? I'm in $3 of debt. Right? Here's negative 3. Now I have more debt. So I was in the hole, and then I had to pay more money for whatever reason. I'm in more debt, so I'm going to go 1, 2, 3, 4, 5 more. Where am I? Negative 4, negative 5, negative 6, negative 7, negative 8. There's my negative 8. Okay, give me a thumbs up if the negatives to positives so far makes sense. Thumbs down if you're lost. Okay, I think we're good. All right, I'm going to have you guys try some. I have 5 problems. Yes, Joseph.
You could think of it as like the trains that are like propelled by magnets and stuff, because if there's a positive and a negative, that means they'd be attracting, and then it'd just be stuck.
They'd be stuck. The positives and negatives.
If it's the same, if it's a positive and a positive, or a negative and a negative, then it's a positive.
Okay, now for multiplication, the positive, you'll get a positive answer. Negative, negative, you'll get a positive answer. for addition, it's going to take on the sign of whatever it is. Okay? So if you've got negative minus, if you have a negative number and you're subtracting another number, the answer has to be negative. Okay? It's different than multiplication. So, all right, so let's do a few practice problems real quick. So I have different signs, a negative and a positive, so I'm going to subtract. What am I going to do? Get ready?
Subtract.
Absolute value, absolute value. 6 minus 2 is 4. The answer takes on the sign of the larger absolute, which is that one, negative 4. Okay, I need a helper for this one. Talk me through this. What do I do? Preston. The thingamajiggers, okay? Subtract, so 6 minus 2 gives me 4. The sign takes on the sign of which number? It's the bigger number. Yeah, it's got the bigger absolute value. It's farther from 0. It's more powerful, so it's positive 4. Good. Okay, how about when the signs are the same? Talk me through this one. Lexi.
So you find their absolute value, you add them together, and then since they're both negative, it's negative.
The answer has to be negative. What's 6 plus 2? 8. So the answer is negative 8. How about when they're both positive? Michelle. She says this is positive 8. Can I just say, hey, and I just do that? Yeah. You don't need all those extra positives. It's just 6 plus 2. What if there aren't parentheses? Can that negative overpower that positive? Yes, it can. So really, I can just simplify it and say that's 6 minus 2. You've done that before, like what, first, second grade? Okay. Question, Emma.
So wouldn't it just be like two negative people, if you put them together, they're going to get together and be negative, get two positive people together, they're going to get together and be positive, and if you get a negative and a positive person, it's just going to end badly.
In multiplication, yes. What you said is all true for multiplication. Okay, so we will get to that lesson. All right, addition with two integers. Here's your general rules. If they have different signs, subtract them. Make sure you're subtracting the absolute values. Take the sign of the greater absolute value. If the signs are the same, add them. Add the absolute values. Take the sign of the addends. So there's your general rules. Don't write it down because it's in your book. Okay, here we go. Next, this is part 2 of our lesson. These are all algebraic terms for short. We just say terms. This is a term, that's a term, that's a term. Even that is a term, so it's just a piece of algebra. 2 plus y, that's a term, and that's a term. Next, what's a numerical coefficient? The numerical coefficient is the number part of a term. So 3 is the number part of a term. So the coefficient is 3. What is the coefficient? Get ready? 3. Wait, there's no number there. Well, I can't see it, but there's one there. It's a 1. So my coefficient is 1. What is the coefficient here? -1. What is the coefficient? Get ready? -1. We're going to get used to circling them. My coefficient here is 3. My coefficient here, wait a minute. There's no variable. Later you'll learn that there's a hidden variable in there. But for right now, our coefficient is just -2. Okay? So I'm going to quiz you now. I'm going to call on 3 students. What is the numerical coefficient of a squared b? How about Connor?
A.
Close.
A square?
No, it's the number in front of the a. What number is in front of the a?
1.
It's a 1. What does it? Get ready?
1.
1. What's the numerical coefficient in front of this one, Addison? 3. It's a 3. What?
3.
3. And what coefficient is in front of this one? How about Gage? It's the number that's in front. There is a negative,
1.
but what? Yes, it's a -1. What's my coefficient? Get ready?
-1.
-1. So we're going to circle the sign. We're going to circle the sign. Okay, so now we're going to talk like terms. So now that we know what terms are, we know what the coefficients are, we know how to add negatives and positives. We are going to add terms. Only the terms that are like. So the question is, what are like terms? Like terms have the same variables. What do like terms have? Get ready?
The same variables.
The same variables. They also have to have the same exponents. What do they also have to have? Get ready?
Same exponents.
Same exponents. Now look, this has an xy, this has a xy. The order's different, but are they equivalent? Is xy equal to yx? Yeah. I would get the same answer if I times like 2 times 3 and 3 times 2 is the same. So the order doesn't matter, they just have to be the same variable. X and y. So these are like terms. What are they? Get ready?
Like terms.
Like terms. In the coefficient in front we talked about is 1. X and x squared. Are these like terms? Nod yes or no. You are correct. These are not like terms. This has an exponent, this doesn't. To be a like term, they have to have the same exponent. What do they have to have the same? Get ready?
Exponents.
Exponents. So they're not like terms, you can't add those. All right, so let's try adding. So because these are like terms, I can add them. So think of it like I have -5 x-rays and yo-yos. And then someone gives me 1 yo-yo and x-ray. How many x-rays and yo-yos do I have? Well, add the coefficients. -5 plus 1 gives me -4 x-rays and yo-yos. Done. Let's try this one. I have 2 x-rays and yo-yos plus some other weird thing, but it doesn't match, so I'm not going to add it. Oh, and then I have another x-ray and yo-yo. I'm going to box the things that are alike, so visually I can find the things that are alike. And I'm going to write them side by side. 2xy plus 1xy plus a -5 weird thing, x squared y. And now I'm going to add my like terms. Like, 2 plus 1 is 3 xy's. And I don't really need both. I can just write -5x squared y. Can I add these? Yes or no? Show me with your head. You're correct. I cannot add these. They're not like terms, so I'm done. Okay, your general guidelines for simplifying or combining like terms are write in the coefficients. So like that leave 1 if it's not there, or the -1 if it's not there. Circle some type of marking. You can do a box or circle for the ones that match. So last class, people were like, oh, that's alike and that's alike. Circle, circle. Oh, and that's alike and that's alike. Circle, circle. No. Circle these because they're alike. Box those because they're alike. Make sense? So you can see which ones go together. Okay? And then rewrite it so they're next to each other. Keep the signs with the coefficients. Add them and check your answers. So let's try a few. Got three or 4. Okay. Like term. Same variable. Let's write in our coefficient. Now we're going to rewrite them next to each other. 3x minus 1x. Are these like?
Yes.
Yes, they are. They're just coefficients, right? So I'm going to do a circle and a circle. They're going to go next to each other. 2 plus 2 plus 3. Now I'm going to add. 3x's minus 1x's gives me 2x's. Plus 2 plus 3 is plus 5. All right, your turn. Will you write down this on your notes? Will you write in the coefficients? And identify the like terms. Identify the like terms. Then combine your like terms. Put your pencil up when you have your answer. Okay, so if you
3xy, 2xy, and xy are alike, so you circle them. And then the coefficients are 3, 2, and then there should be a 1 there.
Okay, awesome.
So you add 3 plus 2 plus 1 equals 6.
Okay,
And then you bring across the xy.
put my xy in.
And then you
Good.
have the extra negatives.
Just pop it right down. Okay, and that's all I can do. Any questions? Most of you had it. Some of you got a little bit stuck. Some of you wrote a minus there and a plus there. You just copied it wrong. That was probably the more common mistake. That's easy to fix. Okay, good. So let's see. I'm going to skip this one, and we're going to talk an application of this. When would you simplify like terms? We'll say you have a flexible rectangular object. Flexible meaning variable. X, the value of x can change. And I want to get a general formula, so no matter what value I put in for x, I would have a formula ready to go so I can calculate its perimeter. Perimeter equals 3 plus 2x plus 3 plus 2x. 3 plus 2x plus 3 plus 2x. Putting like terms together,
6 plus 2 is
3 plus 3 is 6. 2x's plus 2x's gives me 4 x's. Can I make that 10x, because I really want to simplify it? Gage?
Wouldn't it? No, never mind.
Okay.
Was that-
But could I combine these? Gage?
I was wondering if it could be 4x squared because it was 2 x's before.
I want to talk about that though, but what's the answer, Jasmine?
You can if you want it to be wrong.
If I wanted a wrong answer, then add them. No, so, correct, don't add them. They're not like terms. This is $6 and this is 4 x-rays. You can't combine them. So they're different
Yes.
numbers. Colin,
You can if x equals 1.
then you can combine them. Okay, let me add it. Let me ask another question. I'll follow up on this. What if I said that this is 3x and this is 3x and this is 2x? So I've got 2x's plus 3x's plus 2x's plus 3x's. Can I have like an x to the 4th in there? Because I have 4 x's.
Well, no, that's only for like.
Show me, who's got a response? Kaylee.
So I think that there's only 1x and you're not multiplying, so you're just adding. It's telling you just add the numbers, but the variables stay the same.
Oh, that's perfect. She says just add the numbers. There's 5 plus 5, there's 10, and the variable stays the same. The only time I could get an exponent, like x to the 4th, is if I was multiplying. X times x times x times x would be x to the 4th. So I have been seeing some mistakes this morning on that. So yeah, keep your variable the same, just add the coefficients. All right, we're on page 207, and I'll put your problems on the board.